Good afternoon, children.
Good afternoon.
Good afternoon, ma'am.
Good afternoon, ma'am.
Hi, children. Good
afternoon, ma'am.
afternoon. Good afternoon, children. Good afternoon. Yeah, we are continuing with circles, and this is the first question. I'm sure all of you have taken down the question, so I'll show you the answer slide. Okay, so the question says find x. Find x. So we need to first find the value of x. Tell me the property we can use here to find the value of x. Property. Straight away, we can directly find the value of x. What is the property that can be used to find x?
Ma'am, angle subtended by equal tangents.
No. Okay, so fine. Angles are subtended by equal tangents. Okay, fine. So what? They're equal, or what are you trying to say? Complete it.
Ma'am, angle x is double of angle APB.
No.
Ma'am, the theorem,
Theorem, sorry, Rakshita, just a minute. That cannot be used, Sashank, because here because angle APB is formed outside the circle. If P is a point on the circumference of the circle, maybe we can think of using the theorem which you have in your mind. Now this point P is outside the circle. APB is an angle outside the circle. So that theorem is not relevant to this situation. Yes, Rakshita?
Ma'am, we can use the theorem. The tangent at any point of a circle is perpendicular to the radius through the point of contact.
Okay, fine. So this is 90 and this is 90, right?
Yes, ma'am.
Okay. And then angle is some property of a quadrilateral, correct?
Yes, ma'am.
Okay, fine. That's fine. But to answer MCQs, you should be still faster. So there is a property which we saw in one of the questions in the second exercise, that AOBP is a cyclic quadrilateral. We proved that AOBP is a cyclic quadrilateral. AOBP is a cyclic. I'll clarify. I know the questions you're getting in your mind now. AOBP is a cyclic quadrilateral. So opposite angles are supplementary. So straight away, when you look at a figure like this, x is 150. That's it. So you'll mark that and go to the next one. If you like mark 90 here, 90 here, and then you calculate all that, it's going to take a little longer time, maybe 10 seconds, 20 seconds extra. But that also matters in an exam. When you look at a figure like this, straight away, x is 150. Next. It's like that. Now, we know that the vertices A, O, B, and P do not lie on the circumference of a circle. Because what do we understand by a cyclic quadrilateral? A quadrilateral is a cyclic quadrilateral if all the vertices of the quadrilateral lie on a circle. But here we see that only the points A and B lie on the circle. O and P, the points O and P do not lie on the circle. Only the points A and B lie on the circle. What is a cyclic quadrilateral? All the four vertices of the quadrilateral must lie on the circle. But here only A and B lies on the circle. OP not on the circle. Then how is it a cyclic quadrilateral? There is the vertices, meaning you can draw a circle passing through the vertices A, O, B, and P. That's what it is. You can not this circle. You can draw a circle which can pass through all these four vertices. You can draw another circle which can pass through the points A, O, B, and P. Okay. I hope that's clear to all of you. So AOBP is a cyclic quadrilateral. We have proved that it's a cyclic quadrilateral. How did we prove that? Because as Rakshita mentioned, the 90 degrees here. So by angle sum property, you will find that the sum of these two angles is 90. I'm sorry, 180. See here, supposing this was not given, it's given to be y. Supposing this is y. Find x plus y. The question is find x plus y. We're taking a different situation. Okay, so supposing this is y. Find x plus y. The question is find x plus y. So now this is 90, this is 90 because radius perpendicular to tangent. So 90 plus 90, 180. But we know that the sum of the angles of a quadrilateral is 360. So 90 plus 90 plus x plus y is equal to 360. So we get x plus y is equal to 360 minus 180. So x plus y is equal to 180. So what do you get? X plus y is equal to 180. Directly you can, how do you prove that a quadrilateral is a cyclic quadrilateral? If one pair of opposite angles are supplementary, so directly see 90 plus 90, 180, opposite angles are supplementary. So it is cyclic. See, by the theorem, this is 90, this is 90 by the theorem. And as A and B are opposite angles. In quadrilateral AOBP, A and B are opposite angles. O and P are opposite angles. So see A and B, angle A and angle B. Angle A is 90, angle B is also 90. What is the sum of the opposite angles? 90 plus 90, 180. And in a quadrilateral, if one pair of opposite angles is supplementary, it's a cyclic quadrilateral. So AOBP is a cyclic quadrilateral. The sum of these two angles is 90, and the sum of these two angles, sorry, I'm saying 90, I'm so sorry. The sum of these two angles is 180. The sum of these two angles is also 180. Okay, so x is 180 minus 30, which is 150 degrees. This one is 150 degrees. Then you need to find angle BOP and BPO. BOP and BPO. So and it's given join OP, so join OP. Now you need to find BOP. BOP is this angle, BOP. Okay, and you need to find BPO. BPO is this angle. We need to find these two angles, this and this. Now the whole thing is 150. So this will be 75. Because equal tangents subtend equal angles at the center. Equal tangents subtend equal angles at the center. So this angle will be equal to this angle. This angle and this angle. This angle is equal to this angle. The whole angle is 150 degrees. So it will be 75 each. Similarly here, equal tangents are equally inclined to the line segment joining the center and the external point. So this is 15 degrees, this is 15 degrees. This angle is equal to this angle. This angle is equal to this angle. The whole angle is 30 degrees. So each of these angles will be 15. So once again, x is 150 degrees because x plus 30 is 180. Then after joining, we'll see now we know that this whole angle is 150 degrees. This whole angle is given to be 30 degrees. Join. And since the whole angle is 150, 75 here, 75 here. This whole angle is 30 degrees, 15 here and 15 here. So that answers all the questions. Take down, children. Please write down the answer. Done writing, children?
1 minute, ma'am.
Yeah.
Completed, ma'am.
Yeah.
Completed, ma'am.
Yeah.
Yeah.
Yeah, please try the next one, children. I'll just come back. Just a minute. Madhumita, kindly disable your mic. Yes, children. So here again, we use the property that when a quadrilateral circumscribes a circle, the sum of its opposite sides are equal. We have proved this result. NCRT, we have a statement like this and we have proved the statement to be true. So we use that to answer this question. When a quadrilateral circumscribes a circle, the sum of its opposite sides are equal. So that means AD plus BC is equal to AB plus CD. So using this, you can find the length of the side AD. Write down, children. Let me know, children. Once you finish writing, please let me know.
Completed, ma'am.
Yeah. So able to recall this proof, children?
Yes, ma'am.
Yeah. So the result is when, look at the figure, it should be like this. A quadrilateral, and a circle inside the quadrilateral touching the sides of the quadrilateral. A quadrilateral, a circle inside the quadrilateral touching all the four sides of the quadrilateral. Now we know the lengths of 3 out of 4 sides of the quadrilateral. How do we find the length of the missing side? So this is the result. In a situation like this, the sum of the opposite sides will be equal. AD plus BC is equal to AB plus CD. So substitute the given sides and find the unknown. Now remember, this does not hold good to any quadrilateral like this. Supposing you have a quadrilateral like this, AB, CD, with 4, 7 and something like 11 here. You cannot find this side using this result, children. This result can be used only when you can see a circle inside the quadrilateral touching all the 4 sides. Otherwise, no. Not for any quadrilateral. Only if you see a circle inside the quadrilateral touching all the 4 sides of the quadrilateral. Only then this result is true. That is, if the sides of the quadrilateral are tangential to a circle. If the sides of a quadrilateral are tangential, the sides act as tangents to the circle. If the sides of a quadrilateral are tangential to the circle, only then this result holds good. Not to any quadrilateral. So this also NCERT. I think this is the last one in the textbook. Second exercise. Yeah, I think it's the last one in the second exercise. So here we know that the opposite angle, these angles are supplementary. That is, when a quadrilateral circumscribes a circle, the opposite sides of the quadrilateral subtend supplementary angles at the center. Let's see how the figure is here. Okay. I'm just double checking the figure. 1 second. Is the figure correct? 1 second, 1 second. I'm just. Okay, let me just correct the figure, children. This figure is incorrect. I'll just draw one. Excuse me, okay? It's not a perfect circle. Please excuse me. Yeah, the figure should be something like this, children. Okay. 85 degrees. How much is this? So again, like this one again. A circle inside a quadrilateral. Circle inside a quadrilateral touching all the 4 sides of the quadrilateral. Now each side of the quadrilateral subtends an angle at the center. Each side of the quadrilateral subtends an angle at the center. See, the side AB of the quadrilateral subtends angle AOB at the center. The side BC of the quadrilateral subtends angle BOC at the center. The side CD of the quadrilateral subtends angle COD at the center. And the side AD of the quadrilateral subtends angle AOD at the center. So you see that all the 4 sides of the quadrilateral subtend an angle at the center. How is this figure? Circle inside a quadrilateral. Circle touching all the 4 sides of the quadrilateral. Now this quadrilateral is not a cyclic quadrilateral. This one is not a cyclic quadrilateral. Cyclic quadrilateral means quadrilateral inside the circle like this. This one is a cyclic quadrilateral. Quadrilateral inside and circle outside. This is a cyclic quadrilateral. Quadrilateral inside, circle outside. This one is not a cyclic quadrilateral. Here in this figure, the sides of the quadrilateral are tangential to the circle. The four sides AB, BC, CD and AD are tangents to the circle with center O. Okay, so now we know the result is opposite sides in a figure like this, in a situation like this, the opposite sides of the quadrilateral subtend supplementary angles at the center. Subtend supplementary angles at the center. We know that each side subtends an angle at the center. Take the opposite sides. So opposite sides are AD and BC. AD and BC are the opposite sides. The side AD subtends angle AOD at the center. The side BC subtends angle BOC at the center. Now the sum of these two angles is 180. The sum of these two angles is 180. So the sum of which two angles is 180? AD and BC are the opposite sides of the quadrilateral. AD subtends angle AOD at the center. BC subtends BOC at the center. The sum of these two angles is 180 degrees. Which means clearly x plus 85 is equal to 180. X is equal to 180 minus 85, 95 degrees. Kindly take this figure, children. This one is wrong. Take this figure. I'll show you the answer slide. Take down the figure. Done, children?
2 minutes, ma'am.
Okay.
Completely.
Yeah.
Completed.
Yeah. So in the figure, if the sides of the quadrilateral ABCD are tangential to the circle with center O, find the value of R. AB is 29. AB, this one, AB is 29. AD is 23. AD is 23. DS is 5. DS is 5. Okay, so we need to find the value of R. Very simple. Just listen to me carefully, children. Now, let's start with DS. Now, DS is equal to
5 centimeters.
No, I'm expecting some other answer. DS is equal to which line segment?
DR.
DR. DS is equal to DR because D is an external point. DS is equal to DR. What's the reason? What is the reason? Why is DS equal to DR?
From the same external point to the circle.
Tangents from the same external point to the circle are equal. So DS is equal to DR. Since DS is 5 centimeters, DR is also 5 centimeters. Then how much is AR, children? If this is 5, how much is AR?
17. No. 18.
18. 23 minus 5. 23 minus 5. 18. Now, if okay, now the line segment AR is equal to the line segment
AQ.
AQ, which is the external point?
A, ma'am.
A is the external point. So AR and AQ are tangents from the same external point A to the circle. So AR is equal to AQ. AR is equal to 18. Somebody's mic is enabled. Kindly check that and disable your mic. AR is equal to 18 centimeters. So AQ is also 18. AQ is 18. Then how much is BQ, children? If AQ is 18, how much is BQ?
Eleven, ma'am.
11. 29 minus 18. Because the whole thing is 29. 29 minus 18. This one is 11. This one is 11. Now, we almost done. Now, the value of R is also 11. But we'll see how. The value of this is 11. BQ is 11 and hence R is equal to 11. We'll see how. Now, we can prove that OPBQ is a square. Remember that. Register this picture in your mind. Stare at this figure. Register this in your mind. Here we can prove that OPBQ is a square. So to prove it's a square, we'll first prove it is a rectangle. To prove it's a square, we'll first prove it's a rectangle. Now we know that a quadrilateral is a rectangle if every corner is a right angle. A quadrilateral is a rectangle if every corner is a right angle. So in OPBQ, this is 90 because radius perpendicular to tangent. This is 90 because radius perpendicular to tangent. This is 90, it's given. So obviously the fourth angle of the quadrilateral will be 90 because 90 here, 90 here, 90 here. So the fourth angle has to be 90. So this way, the quadrilateral OPBQ is a rectangle. If every corner is a right angle, it need not be a square. It's a rectangle. Now, when is a rectangle a square? If adjacent sides are equal, because we know that in a rectangle, opposite sides are equal. In a rectangle, adjacent sides are not equal, only opposite sides are equal. So here, if you can prove that adjacent sides are equal, at least one pair. If you can prove that one pair of adjacent sides
is equal to BQ.
Yeah, then it is a square. So you can say OP is equal to OQ because the radius of the circle. OP, OQ. OP and OQ are adjacent sides of the rectangle. OP and OQ. Next sides, adjacent sides. So OP is equal to OQ. Why? Because radius of the same circle. Or as Shashank said, BP is equal to BQ. Why is BP equal to BQ? Because they're the tangents from the same external point B to the circle. So since in the rectangle, one pair of adjacent sides, or in fact, both the pairs of adjacent sides are equal, but you can mention any one. They're equal, it's a square. And now that it's a square, all the sides are equal. We know that in a square, all sides are equal. So if all sides are equal, every side is equal to 11 centimeters. Every side is equal to 11 centimeters. And hence the radius of the circle is equal to 11 centimeters. Sometimes they'll ask me to find the diameter. So find the radius and double it. You know that. So sometimes they'll say find they'll just say find the diameter of the circle. Find the diameter of the circle. So we'll find the radius. So diameter is 11 into 2, 22 centimeters. So we start from here, children. This is 5. So this is also 5. But the whole thing is 23. So this one will be 23 minus 5, 18. If this is 18, this is also 18. But the whole thing is 29. And of 29, this part is 18. So this part will be 29 minus 18. So 11. And now everything is 11 because it's a square. See, there are two line segments, children. See here. This AD, no, AD is made up of AR and RD. Now this this RD is only 5. See, this one is 5, right? This is 5. So this is 5. So the remaining AR will be the whole thing, 23 minus 5, 18. So here also two segments. AQ is one segment, BQ is the other segment. This one is 18. So the rest of it will be 29 minus 18, which is 11. Yeah. Please take down the answer, children. This is mostly for 1 mark. It's in, or maybe 2 marks. Please write down everything with the reason, children. Whatever you see on the screen, please make a note in your book. Done writing, children?
1 minute now.
Okay. I'm sure all of you must have finished writing.
Yes, ma'am.
Yeah.
Yes.
Yes, children. Yeah, this is the next one. So here we have to find the perimeter of the quadrilateral ABCD. So if DR is 4, children, which is the other line segment which is 4?
DS, ma'am.
DS is 4. DS is 4. If CQ is 3?
CR is also 3.
CR is
PR
3.
is 3.
Yeah. AP is 6.
AS is 6.
AS is 6. PP is 5.
BQ is 5.
PQ is 5. So now we have all the sides. 6 plus 5, 11. 5 plus 3, 8. 4 plus 3, 7. 6 plus 4, 10. And so the perimeter is 18 plus 18, 36 centimeters. Write down, children. Please write down.
Completed, ma'am.
Yeah. Yes, children. This is the next one. Yeah, please try this one, children. How do we find QSR? Okay, so here you have to recall the alternate segment theorem. Alternate segment theorem. Okay, so for that we need to join QR. We need to join QR. I'll tell you why you have to join QR. So before that, we need to use this alternate segment theorem. You have to look for a chord. Okay. Now, do you find chords in the circle, children? If yes, name the chord or chords.
Yes, sir.
QS and QR.
Yeah. So here in this circle, we find two chords, chord QS and chord SR. Okay. If you take the chord SR, what are the endpoints of this chord SR? Name the endpoints of the chord SR.
S and R.
S.
S and R. Yeah. Point S and point R. Is there any tangent at S or at R?
It's there in R, ma'am. Line
Okay.
M.
Correct. So consider chord SR. Consider chord SR and the tangent through R. And the tangent through R. What is the angle between them given? 60 degrees. See, why are we looking at this angle? Because SR is a chord. SR is a chord. R is one end point of the chord, and through that end point we have a tangent. We have a tangent through that end point. And now we have this angle between the chord and the tangent, 60 degrees. Now this is in this part of the circle. That is with respect to the chord, this is the minor segment. So the 60 degrees is a part of the minor segment of the circle. So now a circle, chord, minor segment. The rest of it is the major segment. The rest of it is the major segment. So alternate segment theorem, you have to find its partner in the alternate segment. So for that, you need to identify the angle subtended by the same chord in the alternate segment. The angle subtended by the same chord in the alternate segment. So can you see this? SR, SQ, RQ. All right. I told you, I have explained about how to, make out the angle subtended by a line segment at any point. So we are talking about the line segment SR or the chord SR. There's a point Q here in the alternate segment. Join the ends of the chord SQ, RQ. Okay, so there's an angle formed here. That is, this chord SR subtends an angle at this point in the alternate segment. Now this angle is equal to this angle. Alternate segment theorem. I'll tell you again. Chord SR, endpoints S and R. Through the endpoint R, we have a tangent. And between, there is an angle given to us between the chord and the tangent in this segment, the minor segment. Why do we say minor segment with respect to the chord SR? Now look at the major segment of the circle. The same chord SR must subtend an angle at any point on the major, at any point in the major segment. So we already have SQ here. From S we have SQ. So join RQ. Now this is the angle subtended by the chord SR at this point Q on the circle. This angle is equal to this angle. You can see clearly alternate segments, minor segment, major segment. So this is 60 degrees. This is also 60 degrees. In the same way, chord SQ, endpoints S and Q. Through the endpoint Q, tangent. And you can see the angle between the chord SQ and the tangent, 50 degrees. This is the minor segment with respect to the chord SQ. This chord SQ subtends this angle in the alternate segment. This angle because SQ, S to R, Q to R in the alternate segment, in the major segment. So if this is 50 degrees, this is 50 degrees. Now by angle sum property, this one will be 180 minus 110. 60 plus 50 is 110. 180 minus 110, 70 degrees. We can do this in a different way also without using alternate segment theorem. Because I've seen children saying that this theorem is not introduced by by our teachers in school. So then will she give us marks if we do it like this? So if your teacher is not open for this theorem, then I'll tell you the alternate method which you can use. Now, please write down this. I think I have used the, okay, I've not used the alternate segment here. I've used the other method. Now, okay, children. Have I done both the methods? No. Okay, so this is, I normally do this by the alternate segment theorem method. But the answer is the alternate method which some schools normally prefer. Some schools do introduce alternate segment theorem to the students. Some teachers do introduce this theorem, alternate segment theorem, because it's useful for 1 mark. 1 mark, if it is for 1 mark, it's very useful. You can do it so easily. So 60, 60, 50, so 50. So directly 60, 50, 110. So this is 70 degrees. Finished. Next sum. Otherwise, we'll have to join. And it's time consuming. Everything is easy to understand. When we say difficult, it takes more time. I'll write here, children. The method I just explained, I'll write it here. Yeah, please take down the question and start writing the solution. We'll see the alternate solution also. One minute, let me write it. Please write down, children. Finish writing, children. Okay.
Completed, ma'am.
Yeah.
Completed, ma'am.
All right. So I'd just like to work on this one. No, so now you can even find. See, you can, if you're asked to find this angle, you know, if you're asked to find the measure of this angle. So proceeding with what we have so far, you know, this is center of the circle. Join like this. So we found that this one is 70 degrees. So this angle will be 140 because angle at the center is double the angle at the circumference. So this will be 140. And now this is a cyclic quadrilateral. ORPQ is a cyclic quadrilateral. Opposite angles are supplementary. So this will be how much? 40 degrees. You can also find this angle. Now we found this is 70. Join OR and OQ. So this angle will be 140 by the theorem, 9th standard theorem. This will be 140. Circumference is 70, so center will be double that, 140. Now this one is a cyclic quadrilateral. This one is a cyclic quadrilateral. Opposite angles are supplementary. This is 140, so this will be 40. So the alternate working, children. So see here, join the for the same situation. For the same situation, without using alternate segment theorem. Without using alternate segment theorem. What we saw here, we found QSR is 70 degrees using alternate segment theorem without using that also. So join OR, join OR, join OQ. That's the first thing. So now we know that OR is the radius through the point of contact R of the tangent MP. So this is 90. It's very easy. Let me just tell you first and then you can write down. So this is 90, but this one is 60. So this is 30. This is 30. Similarly here, OQ is the radius. OQ is the radius through the point of contact Q of the tangent LP. So this is 90 degrees. but this one is 50. So this is 40. This is 40. Now you should also join OS so that we have triangles, so that we have triangles. So you should also join OS. Now this triangle OSR, the triangle OSR is an isosceles triangle because these two sides are equal. OR is equal to OS, radius of the same circle. OR is equal to OS, radius of the same circle. So since these two sides are equal, the base angles are equal. Now this is 30 degrees, so this also will be 30 degrees. This also will be 30 degrees because this is 30. 90 minus 60, this is 30, no? So this also will be 30 because isosceles triangle property. Same thing here. In the other triangle OQS, in the other triangle OQS, OQ is equal to OS. OQ is equal to OS. In the other triangle, OQ is equal to OS, radius of the same circle. So isosceles triangle. So base angles are equal. So if this is 40 degrees, this is also 40 degrees. So this whole angle is equal to 30 plus 40, 70 degrees. Whole angle is 30 plus 40, 70 degrees. So join. First step. 90, 90. 30, 40. Equal isosceles triangle, base angles equal 30. Same thing here, radius, isosceles triangle, base angles equal 40. 30 plus 40, 70 is angle QS. Right down, children? I've called it Y, I think here. Y. Please understand.
Completed.
Yeah.
Completed, ma'am.
Yeah. All of you, anybody still writing?
No, ma'am.
All right. Yeah, we'll wind up today's session with this one, children. OA is 5 centimeters. OA is the radius of the outer circle. OA, so you can see two concentric circles. They have the same center O, but different radii, OA and OB. OB is the radius of the inner circle. OA is the radius of the outer circle. OB, radius of the inner circle, the smaller circle. OA, radius of the outer circle, the bigger circle. OA is 5, OB is 3, and PA is 12. PA is 12. So how much is PB, children? Is P and a point external to the circle?
Ma'am, 14.
Okay. P is an external point. So is PA equal to PB, children?
No, ma'am.
No, ma'am, because they are tangents of different circles.
Very good. Yes. So P is an external point. PA and PB are tangents, but they are not the tangents to the same circle. PA, see now you will say like this figure actually, you know, see if you produce this, it will intersect and it's like a secant. Ignore it. It's a tangent actually here. See now, actually when you just produce it, it might be a secant. It's a tangent only. It is a tangent. So let's not overthink. It is a tangent. Okay. So PA and
BP is
P.
14.
So PA and PB are tangents from an external point P to different circles. So they are not equal in length. They are not equal in length. PA is not equal to PB. PA is not equal to PB. Okay. So what's the measure of this angle, children? This one? What is the measure of this angle? OA is the radius.
90 degrees.
Yeah, PA is the tangent, so 90. So that makes OAP a right triangle. OA is 5, this is 5, this is 12. Which is the hypotenuse? OP is the hypotenuse. Because the opposite of the right angle is the hypotenuse. OP is the hypotenuse. So the hypotenuse will be 144 plus 25, 169, square root of 169, 13. This is 13. By Pythagoras theorem, this is 13. Now in the other right triangle, because this is also 90, radius perpendicular to tangent, radius OB, tangent 90 degrees. So OBP is another right triangle, wherein OB is 3 centimeters and the hypotenuse OP is 13 centimeters. Because the OP is the hypotenuse because it's opposite of the right angle. That's the hypotenuse. So OB is given to be 3 centimeters and OP is 13. So what is BP by Pythagoras theorem? 3 square plus BP square is equal to 13 square. Pythagoras theorem. 3 square plus BP square is equal to 13 square. So BP square is equal to 169 minus 9. So BP square is equal to 160. BP is equal to square root of 160. Let's write it as a mixed assert. So square root of 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 5s are 160. So from 2 2s 1 2 out, from 2 2s 1 2 out. root 10. So 4 root 10. 4 root 10. BP is equal to 4 root 10. So we need to be very careful with the hypotenuse, children. So you can go wrong there. 13 is the hypotenuse. So BP will be, BP cannot be more than 13 because the hypotenuse is the longest side. So OP is the hypotenuse. So BP cannot be more than 13. BP is 4 root 10. Yeah. Your children, please take a screenshot. It's time, so you can complete this by yourself. Take a picture, children. Simply using Pythagoras theorem, that's all. We have two right triangles, Pythagoras theorem, but be careful while using Pythagoras theorem. Identify the hypotenuse correctly. Any doubts here, children? Sashank, I think,
ma'am.
yeah, Sashank, you understood your mistake, right?
Yes, ma'am.
Yeah. So you will not make a mistake. In the exam, if you see this question, you will get full marks because you've made a mistake now, you will not do it in future. So be happy you made it. Taken a picture, children?
Taken.
Yeah. So please complete this. Yeah, class, use the emoji. Raise your hand. Madhumita, Prajit, Danya, Raja, Florentina, Krishmi, Tanishka, Sashank, Rakshita, Arjun, Sriranjan. Very good. Very nice, children. All right, children. So regarding the exams, today you will not have any exams, but prepare with the chapter polynomials. So tomorrow you will have at least 2. I'm still preparing them. At least 2 you will have tomorrow on polynomials. And children have mentioned about the corrections in the exams which have been conducted so far. All that will be done and your papers will be re-evaluated. So you will get the correct score. Don't worry. You will get the correct score. If you have selected the correct option, but it was the correct option was, like marked as incorrect there, I'll correct all that and your papers will be re-evaluated. You will get the correct score. Don't worry about that. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, children.
Thank you.